Sometimes life can take you by surprise. In one instant, everything you know can be turned upside down. Today, we look at someone whose life was transformed drastically. This is the story of Grant. You're Grant's father, correct?
Yes, he was my bright and shining star.
You know he's still alive, right?
Yeah, I'm still alive.
I know, but it was such a close call.
Tell us about what happened.
He was just playing as his adorable dog, Gracie, when all of a sudden... It was so sad. Little did we know, Gracie had rabies. And once she bit Grant, he had rabies too. Because as we all know, the most common point of entry for rabies is through an infected animal bite.
Yes, of course. But rabies is usually fatal. How did Grant survive this horrific attack?
Luckily, I had met top rabies specialist in the world, Dr. Butters. And he had come all the way from India to fix my boy. What has happened to my boy?
Hello, I'm Dr. Butters. Let's see what we can do here.
But how could this happen? Gracie is such a good dog.
This virus can take the best of them.
But what exactly does it do?
Well...
Rabies virus is transmitted when an infected organism passes it on to an uninfected animal via infected saliva. The most common point of entry is the area of the animal bite. The virus then travels through the nerves till it reaches the brain. During this period, there are no symptoms. After multiplying in the brain, the virus spreads to the salivary glands and symptoms become very apparent. Existing nonspecific barriers to the pathogen include our skin and mucous membranes. In the case of rabies, the skin is the most crucial because the infected saliva enters an organism's body through punctured skin from the bite. Other innate nonspecific barriers include nonspecific immune cells such as macrophages, fever, and inflammation. Our specific defenses include helper and cytotoxic T cells, memory and plasma B cells, and antibodies which are secreted by B cells. These defenses make up our adaptive immunity and help react quicker if an organism gets rabies again in the future. The innate immune system has both an external and internal mode. First, innate barriers such as your skin and your mucous membranes on your internal organs inhibit or trap microbes. In addition, lysozyme in your tears and saliva kills some bacteria as well. On the internal cellular mode, leukocytes detect pathogens using toll-like receptors in mammals specifically to identify microbes that have characteristics of pathogens. Phagocytic cells such as neutrophils also destroy microbes. Interferons act similarly in response to viral infections. While the innate system is quick-acting and very broad, the adaptive immune's response is more long-term and more specific. B and T cells recognize epitopes of antigens and through clonal selection create many memory cells. These memory cells are specific for that antigen and are present quicker in subsequent infections. The humoral response of the adaptive system involves when B cells secrete plasma cells that give way to antibodies that travel through the blood and the lymphatic system and are specific to certain antigens. The cell-mediated response involves the clonal section of the specific cytotoxic T cells. Although they may seem separate, the innate and adaptive immune responses are very much intertwined. For example, when you get a splinter, cells near the wound send chemical signals to capillaries to release antimicrobial proteins to the area. In addition, other phagocytic cells are attracted to the area and destroy the microbes. At the same time, B cells may bond with some of these pathogens and replicate, creating memory cells which are specific for the antigens of the pathogens. Thus, the innate system takes care of the current infection while the adaptive system interacts with it to be better prepared to fight future infections of similar type. B and T cells have many receptor proteins that bind to specific foreign molecules. When the B and T cells are activated, they recognize the epitopes of an antigen and divide many times, creating short-lived effector cells and memory cells. The second immune response to a particular pathogen relies on these memory cells. The memory cells specific for that antigen rapidly signal for many clones of the effector cells to eliminate the pathogen.
Maybe you should apply some of the knowledge you just gave us. He doesn't look too good.
Luckily, I have my handy stash from prophylactics. This should do the trick.
Wow, that is truly an amazing story. Are cures usually that successful?
No. Because of Grant's strong immune system and the immediate administration of the prophylaxis, he was able to make a miraculous recovery. Although there is a chance that some antigens are still present.
Wait, what?
It's nothing to worry about. His immune system should be able to maintain balance. As long as Grace has been taken care of, there's nothing to worry about.
So remember, kids, get immediate treatment if you show signs of having rabies. Also, if your pets have rabies, take immediate action so as to stop the spreading of the virus. Or else. Wow, that is truly an amazing story. Are cures usually that successful?
I forgot her.
Yeah, I'm still alive.